Good morning, everyone. One of the frustrations that I have as an educator is the fact that a lot of our schools embrace problem-based learning and, basically provided a lot of training on how to run problem-based learning, but very little is actually done to increase the cognitive understanding of problem-based learning. Um, we're so much on how to do the jump, how to do the steps, but why exactly are we doing this? Why are people so frustrated about problem-based learning? Because they do have some limitations of understanding of how the mind works, and they thought that it would be the easiest way for us is to just deliver the information to our students. That's why, for example, in the Philippines, in the 90s, a lot of schools embraced problem-based learning. And they got so frustrated because they think it's a slow acquisition of knowledge, so teachers began taking over the operation and eventually, give up on problem-based learning because of a very narrow understanding of the cognitive and philosophical basis of problem-based learning. So our objective for this morning is basically to provide an overview of information processing and learning, discuss and contrast knowledge development in this age of AI, discuss the 7-jump because I'm a master student, so I will use 7-jump as a context of how knowledge is developed in terms of developing the difference between knowledge and intelligence, and of course discuss our role as 21st century learners. So let's talk about knowledge and human development. Let's look at this in the context of the information processing or cognitive science. It's basically how do we process. Dr. Neles talked about 60s when the PBL was founded, but during the same time, almost just a little bit earlier, when artificial intelligence was coined. They almost started at the same time, but they do share the same cognitive and philosophical base. So whenever we are faced with a situation in terms of knowledge, let's say for example I have here, let's say a student is given an ECG tracing. What would happen next, right? So if you're given an ECG tracing, probably what the student will do is, wait, do I have any knowledge about ECG? And where do you get that? Where do you get that information? You have to search your prior knowledge. And where is that prior knowledge located? The prior knowledge is located in your long-term memory. You have the facts, the concepts, and the procedures. So you say, oh, I have an ECG. What do I know about this? Do I know what are these lines about? What are the small scale about? Are there information located in my long-term memory? Can I access it? Oh, now you have access something. And you bring it down, you retrieve it. You retrieve it, and you bring it to your short-term memory. Your short-term memory is your working memory. I will explain later in the context of computer science. So from your short-term memory, you try to work on it, you process. I went to my long-term memory, brought it down to my short-term memory, then I go processing and elaboration. And then you probably said, oh, I retrieved something that I don't remember. I retrieved some information that I don't even know. It's in my long-term memory, but I don't know why it is there. So the process is basically circulating that way. You retrieve, you look for information, you bring it down to your working memory, and think about it again, and then you search for more knowledge. And if you correlate it with the clinical context, for example, then let's say from the ECG, then you are provided with information about the patient. This is an ECG of the patient. Then suddenly you are asked by Dr. Patel to go to the patient, ask the patient some history. Then you start, what do I know? So you go back. Do I have any knowledge about this kind of symptom? Do I have anything about this science? Do I have anything about physiology, pathology that is located in my long-term memory? Then you have this procedure of looking at your long-term memory, and then you probably long-term memory, bring it down and bring it to the decision. Say, long-term memory, bring it to my working memory, then bring it back to my decision making as a patient, right? Oh, I know ECG, then this patient complaint of chest pain, this patient's cholesterol is high, or probably some other laboratory procedures. So you're trying to put them all together. So you're trying to ask first your long-term memory. That's why we have here knowledge schema verification. Do I have something there? And if it isn't, there is something new, then that something new is added. That something new is added. The schema, something that you learn from the patient that you don't know, you bring to your short-term memory, add it to what you already know, and bring it back to your long-term memory and increase your memory, right? You increase your knowledge, correct? So it's the cycle. That's the cycle. Or it could be a shortcut. Just schema enrichment, go short-term memory, go straight. Oh, I'm already ready with this. I bring it now to my long-term memory. And you will appreciate it better when we relate it with your cell phone or your computer. So, therefore, in the context of clinical decision-making, you go here within this particular perspective of, I have an information, I ask the patient, I store that information to my long-term memory, then I recycle it, increasing the level, enriching. So basically what is happening is that you are enriching your information. If you go back to that. So basically you're enriching that information. Now, in this particular age and time, or a few years back, maybe 20 years back, we are into computer assisted. What happens now? Instead of just having your long-term memory, working with your brain. I was a student of medicine about 40 years ago. And we don't have any computer when I was a medical student. Xerox is even just newly introduced. You still have to do your notes. The best thing that we can get is the fax machine. But basically, that's the technology available to us. Then we have this computer assisted. What would happen? Aside from your long-term memory, your short-term memory, suddenly you are assisted by your computer and your hard drive. So you're not only storing your information from your brain, but you're also storing your information to your drive, right? So that means you're expanding your base of knowledge. So when you search from your patient, you don't only search your long-term memory, you also search your computer. And that information that you bring together will also be used. Now let's look at that one. You retrieve it to long-term memory for your computer, you retrieve it to your RAM. You know RAM? Random access memory. So if you have your computer, say, how big is the RAM? Because that RAM is the random access memory in the context of our brain, cognitive science, that's your short-term memory. When I was a student, when I was a postgraduate student in the Netherlands, I was so happy I have a laptop. But you know my laptop is 40 megabytes hard drive. 40 megabytes hard drive. I was so happy. No one in my batchmate owns a laptop with 40 megabytes. But it's not in Windows. So when I enter statistics, I don't even see the data. I just say, column 1, A, B, comma, B2, and then even though if I have the 50, and before I'm done, I have actually 51, I have to do it again. Because you don't see any window, you don't see the Excel file. So this presentation is 90 megabytes. When I was a postgraduate student, my laptop is 40 megabytes. So this presentation will not fit in my laptop when I was a postgraduate student. See? But that particular RAM is important because that's where you process, that's where you put things, that's where you work. And at the same time, because of that, you are now making decisions the same way. You enhance, you get information, you mix it together, you integrate it. In both ways, our students are doing that now. I'm learning and taking notes. But the notes now is with your computer. You're writing in your notes. But in the context of artificial intelligence, something is different, right? But the same principle. What happens is that here, aside from this you now ask the AI for information. Technically, you provide information to the AI, right? AI will not work by itself. It will have to be given a task. It will have to be given a question. The same with your student. For them to work, for your student to work, you have to provide him with a task. So if you don't provide the student with a task, they will not do anything. They'll probably just, what will I do with this knowledge? They'll just keep on accumulating the knowledge. So what would happen is that you now have a computer. The thing is, this computer, instead of long-term memory, short-term memory, which is our brain, it is using those global system of server farms, right? So what happens is that the artificial robot, the robot can now make a diagnosis, can now make an analysis. But remember, the analysis that this robot can make is very much dependent on the amount of information that we put into it. AI is nothing without us. Because where will he get the information? Where will he get the compilation of physical characteristic of patient? It's from all of us. We are making AI. If we can make AI that productive, why can we not make our students that productive? Right? So what would happen is that because of this particular system, we thought that it's actually the AI is getting more intelligent. No. It's actually doing this because of this particular things that are not possible during our early years when I was a medical student. Vast amount of data, storage and access. When I was learning computer in the 1988, I was using a floppy disk. And in the Philippines, used to have so many brownouts. And by the time you realize that you lost all your data, because there was only working memory. There is no long-term memory, right? It's only the floppy disk. The DOS. So when it's a brownout, I did not save my file. That's the thing. But now you have the algorithms. Who made the algorithm? It's the people. We make the algorithm. We put the system. The concept map of the kernel is. That's basically what we do. Of course, the computing power, the research and development, and open source collaboration. You're talking about collaboration. So even AI is collaborating. AI is nothing without collaboration. If you have an AI in China and it's close to China, you will only get China data. You probably will not get data of disease patterns in the US or in the Philippines, right? You need to collaborate. It's to be open source. And you say, probably, so powerful, we cannot really compete with AI. But remember this. Do you know that according to neuroscientists estimate that the brain can store around 2.5 petabytes or 1 million gigabytes of information? I don't know even how many zeros will it have, right? Can you imagine? 2.5 petabytes. So probably we are not using well our brain. Next, the vast capacity is due to the brain's approximately 86 billion neurons. And you know that AI is based on neural complexes, right? It's a neural system. And then if you look into the next, the brain doesn't store computer the way, the brain doesn't store information the way computer stores information. This is the way it stores information. It uses a more dynamic and associative method, constantly organizing and forming new connections based on experiences and learning. So your brain continue to develop the schema, to develop the knowledge. But the problem is, if you are not basically putting that connection together, then you may have a problem of accumulation and no integration. So let's bring us to problem-based learning. How it relates now to problem-based learning. If you look at problem-based learning, you know that we have several goals from the original McMaster principle or the McMaster paper. You know that there are 4 educational goals that we want to achieve in problem-based learning. That's structuring knowledge for clinical context, the development of an effective clinical reasoning process, the development of effective self-directed learning, and increased motivation to learn. That's our goal. And let's look at that. Now let's see that in the context of PBL and this one. So this is the thing, right? To remember this. This is what we want. There will be some triggering of information. The trigger will search long-term memory and so on and so forth. Then what will happen? When you're given a problem trigger, then there will be activation of prior knowledge. This why we give a problem? To activate students' prior knowledge. Why do we ask AI a question? To activate AI's knowledge, right? We need to activate. You don't just start with your class and start telling your students all the information, but not necessarily asking your students where they are at this point. What do they know? What do they have? And you basically would realize that. So what would happen will be there will be a cognitive event. And that will be facts, concepts, process, schema, and script are being verified. So when you give me a trigger, I go to long-term memory and I verify. What do I know? Students are not coming to us tabula rasa. They are not coming as white paper. They're coming with knowledge that they learned from elementary, from high school, even by just working in the field. Remember, you can even learn a lot of things from our farmers by working in the field. They didn't go to school, but they probably would teach you about agriculture because they do have that concept. And then what do we do next? We go to problem 2. Then we go activation of knowledge. They have problem analysis, and they have hypothesis generation. They try to test. And you even ask your AI and try to test AI, what he will generate. And you actually can disagree with AI at that point. Right? And you have, again, enhancement, inductive and deductive. Okay. So what would happen next in this particular scenario is that you go into brainstorming, small group discussion, what we already know, what we need to know, right? Oh, I already know this, but there's something here that I don't know. Probably I would search for it, and probably I wouldn't integrate for it. And what would happen here is that there will be active construction of models in order to explain reality. Active construction of models. The students is organizing models, putting relationship between concepts, and then testing the hypothesis. So you see what would happen? And basically what would happen is that will be you increase your illness scripts or scripts available to you. So integration of subject matter in 4, you summarize your conclusion, and then you go around professionally relevant concepts. Then basically in 5, you will have, you realize that, learning is not just about, as mentioned by Joe, learning is not about just, getting all the information. It's also important that you're motivated. It's also important that you perceive the relevance of the learning. You know why students love PBL more than the teachers? Because students immediately recognize the relevance of what they're teaching. I remember when I was a medical student, I'm always complaining, what's the relevance of this biochemistry? What is the relevance of this? I'm almost failing at my test and I don't even know why it is being given. But when you start teaching sugar, carbohydrates in relation to your diabetes, to the clinical science, suddenly you appreciate the context. So therefore, one very important perspective in cognitive science is there should be learning in context, the relevance of learning. You don't just learn because the teacher wants you to learn it. You want to learn it because you know that it is important to your future practice as a clinician. So, and that brings you, by the way, that listing of the goals provide you with one very important requirement or characteristic in Bloom's taxonomy. That's metacognitive skills. You know metacognitive skills? Metacognitive skills is knowing about knowing. Knowing that you don't know about it. You know the problem during COVID? When students were on lockdown, they were studying on their own, and they were not trained to feedback on themselves. They have to look for where's my tutor, where's my teacher? I don't know what to do. Why? Because they don't have the metacognitive skills. It was not developed. Then you go into jump 6 self-study again. You go into perceived relevance, intrinsic motivation, feedback, metacognition. And these are the things that may not be addressed by AI. Maybe AI will continue to develop, but AI doesn't have a metacognitive. It will tell you, it will ask you, am I correct? So, you look at that. When you go to PBL, you actually is promoting the development of cognitive science. So when you look at this, the sharing, after the 7, when you go sharing, you again go to that. You share scripts, you share concepts from others, and your long-term memory is expanding significantly. Now, that will bring us to these two things, two concepts. You talk about novice, the new learner. Why are novice slower? Why are young doctors very slow to make a diagnosis? Why did it take 24 hours to get the history? And a consultant just walked in and said, oh, this is anemia. Oh, this is, and the student wants 24 hours. Why? Because they are novice. And why is it novice? Why is it longer? Because for novice, you have to go long-term memory and before make a decision. What do I know about this? It takes a long time. What is this? What is that? That's why in PBL, when you make long cases, it's very problematic. Because when you make long cases, students don't know a lot of things in the case, and they will spend a lot of days just knowing the concepts. That's why it's a no-no to create very long case. In Maastricht, the principle is something that should be learned in 18 hours, not something that will require 1 week of library work. So you're going to, that's the novice. They are novice because they don't have enough scripts. The thing is, the novice have no integration. You keep on lecturing, and the schema is not enriching. Because information are being stored in the long-term memory individually, not connected to each other. That's why you will have what we call retrieval failure. You sometimes fail to retrieve from your long-term memory, not because you don't know it, because the retrieval cues is not appropriate. It's not appropriate. It's like, you have the money in the bank, but you don't know the password. So you cannot get your money. It's the same thing. You have information in the long-term memory, but you don't know the password. So you cannot get that information. We call it TOT in cognitive science. What is TOT? Tip of the tongue knowledge. And the student says, Mom, it's already at the tip of my tongue. Mom, it's here, wait. And then the teacher says, no. You don't know it. Then the thought disappears. See? You discourage that kind of thing. But when you are using PBL, you're actually developing mastery level, or expert, because when you continue to develop the schema, you enrich the schema, the schema getting bigger and bigger, see? You have more and more schema. So when you see a patient, you don't even have to work and say, oh, I've seen that before. There's the prescription. Student, I have not seen this case. I've never seen anything like this. So you have to search. But Dr. Patel, 30 years of surgery, by just walking along, by just the gait, I know already what's your problem. By just looking at your smell, I know you need dialysis. So basically, because you have so many illness available to you. So what do we want to do? Your problem-based learning is not supposed to increase knowledge. Your problem-based is supposed to increase the number of scripts available. So you have to expose them to so many cases as much as possible. Because the cases will give you the script. And then we will be able to achieve the 4. And that will bring us to my last, more or less focus. So just, if you remember this 2 taxonomies from Miller and from Bloom's, you see the upper competencies, we call it the higher order thinking skill, intelligence. You are intelligent if you're working within the higher order thinking skills. But if you're looking at the bottom, which is a lower order thinking skill, you're actually just having knowledge. I know, but I don't know how to use it. Our aim in PBL is not to make students know more and more. We want them to do more and more and utilize. And that will bring us to this perspective. That will have a pedagogical implication. What will be the pedagogical implication? The last objective. that in this 21st century, we as teachers must realize that our role is not to provide them with what they know, but also how they should know. AI can provide them with what they know, they need to know, but they cannot provide the process of how to know it. That's why I'm telling my faculty members and some people in the Philippines, when they ask me, Dr. Nams, who will be the first to be removed from job because of AI? You, because you keep on lecturing. Because AI can give the information that you lecture. But the facilitator will not be removed because AI is not doing that. So if you want to be still a major faculty member, don't be provider of service knowledge, but rather here we have to be towards guiding, discussing, and reassuring the progress of learners. We need to change our role from being the content expert to also the developer of lifelong learning. And we must become not expert in figuring out, not really experts in knowledge, but experts in figuring out, along with our students, how to do something, how to find out something, or how to use something to do something new. That's the thing that we want. So that would mean me will evolve from being the source of knowledge to facilitator and enabler of learning. PBL is our best shot for developing students' deep critical thinking. So let us do more of it. So thank you very much.